The variation in the value of G. This we study in two segments, one on the surface and the other is above and below the surface. This discussion is regarding changes in G on the surface. You see, the whole earth is not perfect sphere, it is little flattened at the poles and it has been widened at the equator. It's bulging at the poles, you see, and this radius is about 21 kilometer less than that at the equatorial radius. But G changes on the surface because of two reasons. You see, this is Earth center, this is axis, and this is, say, equatorial plane. Now you consider any point P on the earth. This point P, radius, this angle would be known as latitude, angle of latitude. Obviously at the equator it is 0. At the pole it is 90 degree. This angle would be 90 degree. And when you choose this equator, it becomes 0. G changes on the surface because of two reasons. One is unsymmetric size of the earth and the other is rotation of the earth around its own axis. Now, first thing, the change in size of the earth. It's obvious that polar radius is smaller. And since you know the value of G depends on square of radius. Radius is less here. So obviously the value of G would be greater and that on the equator the value would be less. Two things, G minimum at the equator on the basis of this size unsymmetry and it is maximum G over here. Then you might ask the question, where is the standard value of G? In fact, the value of G found to be standard that we consider 9.8. This is taken when the angle is 45 degree. Angle of latitude 45 degree, then only we consider the standard value of G. Here, this is 9.78. Here, it is 9.83. It's a quite considerable variation from equator to Earth. Then because of rotation, you see, when we consider the rotation, centrifugal force is involved and on the basis of that we have the relation G minus RE omega square cos square lambda. Lambda is angle of latitude variable at different points. If you put lambda 0, cos 0 will be 1. That means maximum decrease would be there. That's why G minimum. And when you put this lambda 90 means consider the poles, cos 90 becomes 0, this term disappears and this is equal to G itself and that's found to be 9.83. So both the variations we came across just because of the size and that because of the rotation. You must note it down that the changes due to both the reasons are in the ratio 1:2.